Okay, so we just finished the notes on cells. Now we're going to go on to water and how it's affected in the environment. Okay, so the importance of water. Water is the basics of what our bodies are made of, what the earth is made of. So it's the molecule that supports all life, okay? And it's also a biological medium, which means it can help breed more life. It can help support more life, okay? All living organisms require water more than they require any substance. So we know 3/4 of the Earth's surface is submerged in water. I mean, looking at the globe, you can see that. Any of the oceans, okay? The abundance of the water is the main reason the Earth is habitable. Because once again, all living things require water. So facts, we know water is a polar molecule. You should remember that from the last unit. Okay, so the polarity of the molecule is the result of the hydrogen bonding. So to think of that, let me zoom out. There we go. Okay, so if you look at the picture below, these are your hydrogens right here. This is your oxygen. So your hydrogen ions actually have more of a positive charge, where your oxygen has more of a negative charge because they're sharing those electrons. So when you look at the polarity of the water, it allows them to form hydrogen bonds with each other easily. And we know hydrogen bonds are the weakest bonds, therefore they're easy to break. But these hydrogen bonds contribute to the various properties water exhibits. So 6 emergent properties of water that contribute to Earth's fitness for life. Cohesion and adhesion, that should look familiar from vocab. Surface tension, temperature moderation, high specific heat, evaporative cooling, and it's a universal solvent. So if I ask you what are the properties of water, this is what I want you to know. So when you think cohesion, it's the bonding of a high percentage of the molecules to the neighboring water molecules. Okay, it's all due to hydrogen bonding. So it's like molecules bonding to each other. Water attracts other water molecules. Okay, it helps pull the water up through vessels of plants. Okay, surface tension. It's the measure of how hard it is to break the surface of a liquid. It's related to cohesion. Because cohesion, water molecules attract water molecules. That's what makes that surface tension. That surface tension is what allows things to float on it, insects to walk across it. Okay, that's all in the surface tension. When you talk moderation of temperature, water moderates air temperatures. Stop and think, if there's a lot of dew and stuff on the ground, the air temperature is usually cooler. It absorbs the heat from the air that is warmer and releases the stored heat to the air that is cooler. So it's kind of like your fridge. You put something hot into the fridge, give it a little bit, and when you pull it out, it might not be cold, but it's going to be cooler. Same thing. So when we talk heat and temperature, if you remember back into integrated, when you talked heat and temperature, it's kinetic energy. Okay, we know kinetic energy is the energy of motion. So heat is the measure of the total amount of kinetic energy due to molecular motion. We know temperature is the measure of the intensity of the heat. Those 3 terms are all connected. The higher the kinetic energy, the higher the heat's going to be, the higher the temperature is going to be. So the specific heat of water, it's the amount of heat that must be absorbed or lost for 1 gram of a substance to change its temperature by 1 degree Celsius. Okay, so if we're talking water, it's the amount of heat that must be absorbed or lost for 1 gram of water to change its temperature by 1 degree Celsius. So we know water has a high specific heat, which allows it to minimize temperature fluctuations. Okay, and those minimized temperature fluctuations are what allow life. Stop and think. The deeper you go in the ocean, the cooler that temperature gets. Things that live in the bottom of the ocean in deep depths don't live up by the surface also. It's one or the other. Heat is absorbed when the hydrogen bonds break. Heat is released when the hydrogen bonds form. Okay? Is this making sense a little bit? Good. All right, evaporative cooling. So evaporation, we all know what evaporation is, when water goes from a liquid to a gas. We've learned that since elementary school. We know it requires energy to do so. But now I want you to think of the heat of vaporization. It's the quality of heat a liquid must absorb for 1 gram of it to be converted from a liquid to a gas. Okay, so at 100 degrees Celsius, water is boiling and is letting off steam. So think the opposite way, evaporative cooling. It's due to the water's high heat evaporation. It allows water to cool a surface. So something, if you take really hot showers, if you look at the ceiling of the shower, you're going to see this water condensating right there, okay? Same thing when you sweat. Sweat cools the body as the heat energy from the body changes sweat into gas. So let's talk about insulation of bodies by floating ice. So we know ice is frozen water. It's a solid, but it is less dense than liquid water. So it's going to float. Ice is going to float on water. It can insulate water and organisms below the ice layer to help maintain their temperature. So if you look at the hydrogen bonds in ice, okay, they're more ordered than in liquid. That's why it's less dense. Okay, they've spread out. If you've ever put in a certain amount of water, put it in the freezer, you're going to notice that ice expands as it freezes. This is why. Okay, life can exist under a frozen surface because the ice floats. Now I want you to think that water is a solvent of life. It is a very versatile solvent due to its polarity. It can form aqueous solutions. Okay, and that's why it's called the universal solvent, because so many different substances can dissolve in water. So I want you to look at the picture and look at the different regions of the polar water molecule and how it interacts with ionic compounds called solutes and dissolve them. So over here is your water molecules. Over here is NaCl, aka salt. Okay, the water molecules actually break up the sodium in the chloride, and that's how it dissolves it through it. So we also know that water can interact with polar molecules such as proteins. If you look at the picture, the oxygen is attracted to the slight positive charge of the lysosome molecule. Okay, so if it's lightly attracted, it's going to want to go to there and it's going to help dissolve that out. So last thing, hydrophilic and hydrophobic. A hydrophobic substance is nonpolar. It's usually your lipids, and they do not have an affinity for water. Okay, a hydrophilic substance is polar, is polar or ionic. That's your carbohydrates and your salts, and it has an affinity for water. Hydrophobic doesn't like water, hydrophilic likes water. So those are the properties of water. Make sure you know them frontwards, backwards, inside and out, because this is the basis of so many more things.